Hey, Jody here. Thanks for watching another video from weldingtipsandtricks.com. I'm wrapping up a job here. I had to do 50 of these parts. I say I had to. I got to do 50 of these parts where I weld ends on the parts, two different types of ends, and then they go back to the machinist, and I get them again. He gets them again. He does some machining in between welding operations. So I'm going to show you all the clips from start to finish here today. Little cleaning ups to make the welding go better. The first machine I'm going to be using is this AHP 200. I'm going to be using a torch switch, especially for tacking. And I've got the tungsten way up in there, a little bit below flush, so that I can just prop it straight on there, hit the trigger, and then get a quick tack. Now that works great for low carbon steel. You can't do it with every kind of metal, but this is low carbon steel, so it works pretty good for get all these things tacked up so that I can then weld them out. Now, I'm not going to weld them by hand like this. I'm just kind of showing one part here on how you would have to put them on some V-pads or something and gradually turn the torch in your wrist to try to keep your angle, your torch angle, right as you go up. And then even then you can usually only do about a quarter of a turn at a time. And so I'm just going to get them all tacked up and then put them in a turntable. Now again, I'm just using the torch switch here, no foot pedal or anything. And I'm going to walk the cup with a number 6 cup there, and really it's just the easy way to do it. So I'm leaving the wire in the puddle, it's called lay wire, and I'm wiggling the cup back and forth, and it provides for a nice uniform weld with a lot less fatigue than if I was trying to prop. Now on this end I can't do that, so I'm just going to prop directly on the round part as it's turning. Now you might have noticed a little spark there. Let's play that in slow motion. See this spark? That's because I did not tap the foot pedal before I got started. More modern machines have a pre-purge function. That's what a pre-purge does. It gives you a little bit of argon flow before you initiate the arc. And you can see why that's a good thing. That spark is probably not going to hurt anything here. It's definitely not a good thing, and it will make the sharp tip of your electrode erode a lot faster if you don't have argon there when you first initiate the arc. I've got the machine set to 1 to 2 pulses a second. And I've got a TIG finger XL on, which means I've got it on my pinky and my ring finger, and this offers quite a bit of heat protection. You can learn more at weldmonger.com. But you see that I don't have a gas lens on here yet, and it's not doing that great on coverage, but it's going to be painted anyway. All right, so I did this many parts using the AHP back to back, and that really cooked the torch. I mean, it didn't ruin the torch. It just got really hot in my hand and got the collet so hot that it corkscrewed here. So, why is that a problem? It's just that once they corkscrew like that, they usually won't tighten up on your tungsten. So, I'm going to switch over to a machine where I have a water-cooled setup. And so the next machine going to be the Everlast 210 EXT, and I'm swapped over to a gas lens, a number 6 gas lens. Still going to walk the cup here. Same thing, but things are going to go a little nicer in my hand. My hand's not going to get so hot from the torch baking. And this is the way that looks, just a little wiggling like that. I'm using a number 6 cup here, and the reason for that is that I just don't need any bigger of a cup. It seems to fit in there and wiggle just fine. And with a number 6 cup, I can use probably 12 to 14 CFH and not use much gas. And I'm running just a little bit low on gas. These parts are going to get painted, so I'm not really worried about discoloration or it turning gray. It's not a big deal at all. I tightened up the weave a little bit for that one, just experimenting. Alright, for the other end, I switched cups here just so I could try to film the arc a little bit better. I'm using a number 8 Pyrex cup here, and around 20 CFH on the argon flow. And that looks something like this at 2 pulses a second. I settled in on 2 pulses a second, found that to work the best for this turntable work here. You can see I'm propping directly on the part as it's turning, and that's not the ideal way to do it, but if I only had, say, 5, 10 of these parts to do, I wouldn't bother setting up my torch holder. Just prop kind of like this, prop gently on the part as it spins, and you know, the TIG finger XL there lets me do that. It slides nice on the metal, and then I don't have to worry about my fingers getting hot. Coming up later in the video, I'll show the torch holder and then the final welds after that are done right before it goes to the machinist. Now then I switched over to the Welding Lathe here. And this is the way to go if you got a lot of parts. And I did. I had, like, again, I had 50. I should have done them all like this, but part of what I do is make videos, so I try to show some different methods. It kind of breaks things up, makes it a little bit more fun. But you can see the torch is dead steady, pointing right where it needs to go. And for this, I cranked the machine up to 210 amps and 60% on background and 60% on pulse on time, and it did a really good job. All right, so once I was finished with all 50, actually I did batches of about 20 at a time and gave them to the machinist, but then he did this. He fixtured them up, indicated them with the little quick fixture there with a pin, the piece of drill rod that locates the hole, and then he locks them down on this big block of aluminum here. And this is my friend Ricky, and he said people are going to ask why I have that big block of aluminum on there, so you can just tell them I did it for one particular job, and it's so easy to drill and cut grooves in and everything that I just left it on here, and it's just really handy for all kinds of jobs that have come along since the job that they did it for originally. So on the CNC mill here, he's going to do about 3 different steps, and the tool changer is going to come over and grab a small bit, and it's going to run down there and it's going to mill some very small flat spots on the tube. And the reason for that is these areas get engraved with some identification markings. So once the flat spots are milled there, the tool changer goes up and grabs a really small engraving bit and then runs down there and identifies the part, whatever, I don't even remember what it says, but it's per drawing that has a requirement to identify the parts with a certain numbering system here. And then the final thing is a little 1/8 inch, I don't know what you call these, but some kind of cutter, and it's going to split the tube right down the middle, because it's going to split one side and then it's going to go up and split the other side. Now he's got it programmed to not split it completely. This is a close-up of the bit. It doesn't split completely, leaves a little bit on all 4 corners so that he can then work with it better later on, and so I can fit the hinge pieces on there easier. So once it's finished with the splitting operation, then I get them back. All right. So I've got them back at my shop now. You can see a little bit of metal left on all 4 corners, so it's still round. And actually 1 or 2 of them got cut all the way. I had to fixture them up and put them back together so that he could finish up on them. Here's a little quick peek at the drawing on my phone. You see there are no weld symbols. It shows weld locations, but there are no real weld symbols on it. That's not that uncommon. All right, let's look at how to fixture this thing up. You could make an elaborate fixture and take a lot of time in doing so, but these are fairly simple parts, and the main thing is that the hinge pieces are going to get on there clocked correctly and spaced correctly. So for the spacing, we just used 3 different pieces of tube that were parted at the right dimension, and then the hinge pieces go on just like that. Now, the drawing called for, I think, 20 to 40 thousandths. That's half a millimeter to 1 millimeter spacing. So we just grabbed some 032 washers and used those for the spacers. I actually wound up trying 2 or 3 different methods of fixturing these parts. This seemed like it was going to work and be good enough, and wound up having some problems from the customer. So we'll talk it through anyway. After getting a few tacks on here, again, just doing fusion tacks with no filler metal, because this is just mild steel. Getting about 3 tacks on each side in the weld area. The weld actually only goes part way on those little hinge pieces. So these lengths of tube, all 3 of them are used to space one, and then only one to space the other end of the hinges. And it worked really well, just a really simple way to get the hinges located at the right dimension. Now, the way we used to locate them turned out to be not quite accurate enough. The hinges were binding up a little bit because the pieces weren't kept as a match set. So we had to shift gears a little bit and come up with something just a little bit more accurate. So these knurled head screws with a slot in them and a piece of machined material, more precise material to make sure they were clocked right, ended up working pretty well. Now for welding, for tacking and welding these pieces on, I'm using the Lincoln TIG 200 square wave. And I could just leave it about 170 amps and use the foot pedal. I kind of would like to go full pedal, so I'm going to drop it to 160, and just from previous jobs I know that that'll work pretty okay. Now I need to cut a bunch of 1/8 TIG wire for spacers on this particular job, so I'm going to talk about ways to cut here. Now these are some really cheap dikes here. They're Taiwanese dikes that I've had, and they've had the handles melted, but they're not bad. The jaws have held up pretty good. They're not dinged up or anything, but they're really tough if you want to cut 1/8 inch stainless wire. And you know, as you get older, you start having issues with wrists and carpal tunnel and all that. And you just kind of look for a little bit easier ways to do it. When you're young, you think it's a manly thing just to grab a hold of a pair of dikes and snip some heavy-duty stainless wire. And this will just wear you out. So it works, but it's tough. Now, what's 10 times better are these mini bolt cutters. These just came from Ace Hardware. They were probably about $15. Really a whole lot better than the other cheap dikes. Still, you have to take a bite on them and then chuck them back up in there, but it's just really easy to cut with one hand, even 1/8 inch stainless. All right. Now, what's about 10 times better than that are these little Knipex pliers. These are made in Germany, I think. I think they're pronounced Knipex. I'm not really sure. But I did want to mention them because they're just so good. I mean, anybody that has to cut a lot of 1/8 wire, it's worth it to spend the extra money for these Knipex pliers. Really a whole lot less fatiguing on you. You can easily with one hand snip 1/8 inch wire. And Alex Brown, a friend of mine, he's Caveman Welder on Instagram for anybody that's interested in that. He sent me these. He said, I think you're going to like these a lot. And it's just so easy. They have a little groove up in there. 1/8 inch stainless wire. You can just snip them easy peasy. So, you know, if you got any hand issues, any pain in your wrist or anything, these little mini bolt cutters from Knipex are awesome. Okay, let's get to welding this thing out here. I've got a lot of these things to do, so I'm going to experiment with at least a couple of different techniques and things like that. Here I'm using some 045 wire. That's about 1.1 millimeter. And I'm just trying to move on at a fairly good clip. Steady current, no pulse, works out just fine. There's really no reason to use pulse on this particular weld when it's manual like this, but again, I like to experiment. So what I'm going to do is I'm going to try a little bit of pedal pumping, and that's basically manual pulsing with the foot pedal. So I've got it set at about 170 amps for doing that, and I'm just basically just romping to the floor and then backing off enough where I don't see the puddle completely solidify. I don't want any crater cracks or anything like that. It's not a bad technique to use on thinner wall tubing, like for chassis, for motorsports and things like that. It's just really not necessary on a job like this. I just would like to learn more how to do it, so I figured I'd try one. I really kind of prefer this again, just a steady heat. This is somewhere around 160 amps probably, and just moving on. Move ahead, dip, move ahead, dip, move ahead, dip. No reason to do anything much different. Now I'm using the Lincoln Square Wave 200 here, so I want to show you something in just a second because it has a pre-flow setting on it, and I've got it set to 0.2 seconds. So here when I start this arc, you'll notice no sparks. Just a nice crisp start, and that's going to make the tungsten tip last just a little bit longer, due to the fact that there's argon shielding there when the arc initiates. Well, this is the final step of welding on these parts. They go back to the machinist now to get completely split apart just with a grinder slitting wheel, and then lots and lots of deburring. So thanks for watching, and you can learn more about the TIG Finger and TIG Finger XL at weldmonger.com.